Another Leetcode problem, 2533, number of good binary string. So for this problem, actually, it is a climbing stairs problem, or it is a unbounded knapsack problem. So why it is like that? Let's try to understand it. So we are giving four integers, minimum length and maximum length. So this is just a range. So for example, our minimum to maximum. So this is gonna be a minimum and maximum range gonna be, in this example, it's gonna be 2 to 3, and we are also giving one group and zero group. So for one group in the first example it is 1, and for zero group it is 2. This means it has two zeros as a group, and this means it has a 1 as a one group. So we want to have some combinations of one group and zero group to make the length of the string between the minimum length and the maximum length. So for example, if we choose a zero group, for example, we have to choose two zeros together. So this is okay because the length of this string is more than or equal to 2 and less than or equal to 3. And we can also choose like 0, 0, 1. This is also okay. As we can see from here, 0, 0, 1, it is also okay. And we can also choose 1, 1, and it is also okay. And we can also choose 1, 1, 1. This is also okay. And what's left behind? We can choose a 1 and 2, 0. This is also okay. So in total, there are going to be 5 combinations. So this is just similar like climbing stairs. So for climbing stairs, we can choose one step or two steps, but we're gonna reach some target. It's gonna be here, and this is gonna be the same. We just need to reach a range. So for example, the range is gonna be 2 to 3. We can choose one group or we can choose a zero group, but finally we're gonna reach this range. Or we can understand it as a zero unbounded knapsack problem. So for each of the time, we can choose one group or we can choose a zero group, but finally, the length of the string gonna be between 2 and 3. Yeah. Now let's just use the 0, 1 knapsack idea to solve the problem. So we're gonna use a class and we're gonna prepare the DFS because this is gonna be the easiest way to solve the problem. So T will be the target number. So this target number gonna be between the minimum length and the maximum length. Yeah. But inside we need to choose this t. So this t gonna be between the minimum and maximum length. So this t is just one of the values. Yeah. So we just need to calculate all of the values between the minimum length and the maximum length. So t is just one of the values. So if t equal to 0, this means, for example, t starting from 2, this 2 becomes 0. This means we've already found a combination of one group and zero group. So we're gonna return a 1. This means we already found a combination. But if t is less than 0, this means it is not possible. So we're gonna return a 0. Now we're gonna enumerate all the possible cases. So we're gonna prepare a result. So for n inside the one group and zero group. So result gonna equal to result plus the DFS with the target. So from the target we're gonna minus this number, and finally we need to return the result. And finally we need to sum all the possible values from the minimum length to the maximum length. So it's gonna be the DFS t for t in range with the minimum length and maximum length plus 1. Yeah, but this is going to be a really big number, so we need to prepare this number with a variable mod. So this is going to be 10 to the power of 9 plus 7. So this means for each of the calculation we need to modular a mod, and here this result is okay because we've already modular the mod. But finally, for the final result, we need also a modular the mod to get the final result. Now let me just run it to check if it works. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it passed all testing cases. And the time complexity is just O(n). So n gonna be like here 10 to the power 5. So why it is O(n)? Because this is a cache. So while we are calculating, we didn't clear the cache, so everything is inside the cache. So no matter how many loops, the maximum number for this target t, let's just check the target t. So the target t, the maximum length gonna be 10 to the power 5. So this means the time complexity gonna be 10 to the power 5. And why we can use this method? So this is just an unbounded knapsack problem. So this is our DFS. And for each of the time, this is the conditions for each of the target. Yeah, but we cannot choose a target between the minimum and maximum length, and we're gonna return a 1, and this is not right. So for example, if we were to have a check like something like if t is more than and less than or equal to the maximum length, and we're gonna return a 1. If yeah, so this kind of a condition is not right because we are not checking. Because this kind of in DFS, we're gonna return a value too quickly, because if we find a 2, we're gonna return it. But there are gonna be some other cases like 3, like the length gonna be can be 3. So this means we cannot check it like that. We have to enumerate all the possible cases one by one in this case. Yeah, so we just enumerate every possible cases inside the minimum length and the maximum length, and then we just do an unbounded knapsack problem. So if it is equal to 0, it means it's totally okay. So we're gonna return a 1. So if it is less than 0, it means it is not okay. So we're gonna return a 0 because this t minus n is gonna be smaller and smaller. But we need to have a return. It can be 0 or it can be less than 0. And this result is just need to accumulate all the possible cases, and after that we're gonna return the result. I think this is a very good problem, and there are many similar Leetcode problems like this, and we have to practice this kind of problem. Thank you for watching. See you next time.